Hello! Alright, so the purpose of this video is to basically get you used to dividing polynomials of a degree higher than 2. Okay, so let's start off with this factor theorem here. Okay, so what this says is, let's say you take a polynomial, so any polynomial f of x, so something like this, right? And you divide it by this expression here, x minus 1. So that means if you divide it through, and we have this expression here, is going to be a factor of this if we have a remainder of 0. Okay, so in context, so I'll just kind of help you out with this visual example what this means. Okay, so is x minus 1 here, so this would be x minus a, so is x minus 1 a factor of this expression f of x? And actually, if you're wondering, we saw that this was true last class. So recall that if you guys forgot how to do synthetic division, right? So what we have is we start off with something like x minus a, and that's the same thing as, so for this expression here, we have x minus 1. So in order to identify a, so a is right here, right? So a is 1. And then what that means is we take this value and we're going to stick it right there. So that's how we get 1. Now, some of you, if you recall, now you might be wondering, how did we get this up here, right? So the way that we got that up there is we look at our leading coefficients, right? So this is a 1, 5, negative 1, negative 17, 12. So we have to write all those coefficients here. And then we do this here. Okay. Perform the synthetic division. So kind of look at the arrows, how that's done. And what we get is we get a remainder of 0. So what this means is this expression here is going to be a factor of this expression only if that's true. So if the remainder is 0. So what we get out of this is that if we divide this by this, then we're going to get x cubed plus 6x squared plus 5x minus 12. Okay, so let's take this down here and expand on this a little bit more. Okay, so what we have, so what I'm going to do is, so just think about it, right? So what we had, we start off with this, x raised to the 4th plus 5x cubed minus x squared minus 17x plus 12. And if we divide that by x minus 1, well, that's the same thing as x cubed plus 6x squared plus 5x minus 12. So what we could say is, let's say we did the opposite, right? So if let's say we multiply this by this, then by doing so, we're going to get this, okay? So what this implies, as you can see here, this means x raised to the 4th plus 5x cubed minus x squared minus 17x plus 12 equals, so our quotient, so x cubed plus 6x squared plus 5x minus 12, and we're multiplying it by a divisor, which is x minus 1. Okay, we're going to use this idea in some shape or form as we progress through the rest of this problem. All right? Okay. All right. Okay, so let's go through the rest of this problem. So next, what we want to do, in order to try factor this completely, we need to consider this expression now. Okay, so let's try to factor this. Okay, so let's say I just give you something like this. So let's try to figure out if x plus 4 is a factor of what we have here, x cubed plus 6x squared plus 5x minus 12. Okay, so if we use synthetic division on this, if we try to do this, what we have is we have x plus 4. Okay, this is the same thing as x minus a negative 4, right? Recall that for synthetic division, we need x minus a. So what this implies here is that a is negative 4. Okay, so now let's try to use synthetic division on this. in order to try and figure this out. So we have 1, 6, 5, negative 12, and then let's go ahead and use synthetic division. So we're going to drop down the 1, multiply, so we get negative 4, add down 2, so this is going to be negative 8, negative 3, 12, and then we get 0. Okay, so now what this implies is if we were to write, if we start off with this, right, so x raised to the 4th plus 5x cubed minus x squared minus 17x plus 12. So this is the same thing as, so what we have is we can replace this part here. So we can replace this part. So we know that x plus 4 is a factor. So this is true. X plus 4 is a factor because the remainder is 0. Now, if we get a remainder that is not 0, that means we probably have to try a different number. So I was nice enough to just kind of give this to you. Okay? So what we have is, so from this here, this becomes x plus 4. Okay? And then what we have is this is 1x squared plus 2x minus 3. So that's going to come next. So we have x squared plus 2x minus 3. And we're going to write this term that we left out earlier, right? So what that is this is x minus 1. Okay? So as you can see, we're getting closer and closer to figuring this out. Okay, so next what I see is we need to consider this expression, right? So if we were to consider this expression, well, we need to find two numbers that multiply to negative 3 and add the 2. As you see, we have a trinomial, so we can save ourselves some work here if you guys remember how to factor, right? So if you guys remember how to factor, just find two numbers that multiply to 3, add to negative 2. Do that correctly. I believe that's 3 and negative 1. Divide that by our a, which is 1. So when we write this is the same thing as x plus 4 times x plus 3 times x minus 1 times x minus 1. Okay, now we can regroup this. So as you can see, these factors are the same. So since those two factors are the same, we can rewrite this expression x raised to the 4th plus 5x cubed minus x squared minus 17x plus 12. So this is the same thing as x plus 4 times x plus 3 times x minus 1 squared. All right? Okay. Please let me know if you have any questions so far. Okay, bye. Hello. All right, so we can actually expand on this. So let's say we were to graph this function. So we have this function on the left-hand side, and we can see that this is the same thing that we got here. So that was the importance of trying to factor this. So being able to factor this completely tells us some nice things about this function. So we can see is if we set this equal to 0, well, we have an x-intercept at negative 4, at negative 3, and at 1. So if we wanted to, remember from the other assignment, we could graph this. So if we graphed it, and as you can see, this is an even function. So we have a 1 and a 1, 2 here, right? So x raised to the 4th power, even functions, as you can see, the y values go in the same direction, if that makes sense. So it has something of this shape, and of course you could go and test values if you wanted to, and you could actually see that you could graph it. Okay? All right. Okay, so let's take a different example now. Okay? So let's say we want to find the zeros, all the possible zeros of this particular function. F of x equals x cubed plus x squared minus 4x minus 4. So there's a theorem somewhere that says that you can consider all the factors of our constant term, 4. So this is our constant term. And that tells you the possible zeros or x-intercepts. Okay, so as we can see here, so since 1, 2, and 4 are possible factors of 4, that means we want to consider the positive and negative values of 1, the positive and negative values of 2, and plus or minus 4. Okay, now also what I'm going to show you is there's also an extension of this. For the sake of time, I don't even have time to teach it to you guys, but let's say instead if it was like 2x cubed plus x squared minus 4x minus 4, generally what you would do is you'd actually look at this number and this number. So you'd have to consider like plus or minus 1, 2, and 4, and you divide it by plus or minus 1 or 2. So what we have is if you took this part here, our possible zeros would be like plus or minus 1, 2, and 4. And if we did this here, that means another possible zeros could be 1 divided by 2 is 1 half, 2 divided by 2 is 1, and 4 divided by 2 is 2. So this would be the other case. But just for the sake of simplicity, don't worry about it. What I'm going to do is I'm just going to make sure that when we do these examples, this coefficient in front of here is going to be 1. Okay, so let's try to test this to see if this works. Okay, so for example, let's try any number. So let's try 1. Okay, so if we try 1 in here, so what we have is if we try to test it, so we have like 1, and then now let's go ahead and try to perform the synthetic division. So we have a 1, 1, negative 4, negative 4. Okay, so first we're going to drop down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 4 plus 2 is negative 2. 1 times negative 2 is negative 2. And then what we get out of this is a negative 6. So now I'm going to write something here just to help you out. So you see here, the remainder is not. So the remainder is not 0. So this implies that, recall, so that this 1 implies, so this means a is 1. So if we have x minus a, we have x minus 1. So this means x minus 1 is not a factor of this expression that we have up there. So what this implies is if we ever get a remainder other than 0, so that unfortunately means that we have to go through this process and try again and choose a different number. If you're wondering in the Google form though, I was really nice about that, and I actually just for most cases, I just saved you the trial and error process. Okay, but now let's try to see if we use a different number. So instead of positive 1, let's try negative 1. Let's see if negative 1 works. Okay, so we try 1, 1, negative 4, negative 4. As we do this, we're dropping down the 1. Negative 1 times 1 is negative 1. Negative 1 plus 1 plus negative 1 is going to be 0. Negative 1 times 0 is going to be 0. Negative 4 plus 0 is going to be negative 4. Negative 1 times negative 4 is going to be positive 4. And we have negative 4 plus 4, and that gets us 0. So what this implies is that this looks like this will work. So this is going to be a possible factor. So what this means is if we start off with x cubed plus x squared minus 4x minus 4, so that's the same thing as multiplying. So we have x minus a negative 1, so that's x plus 1, right? So it's the same thing as multiplying x plus 1 times what we have here. So we have 1x squared plus 0x minus 4. It's the same thing as multiplying this by x squared minus 4. Okay? So pretty soon I'm going to continue where we left off. Okay? I'll see you later. Hello. Alright, so continuing where we left off. Okay? So what I see here is we could actually factor this expression now. So if you recall from a while ago, this is the difference of squares formula, right? So x squared minus 4 is the same thing as x squared minus 2 squared, right? So what we can do is this is the same thing as x plus 2 times x minus 2. Okay, so let's go ahead and write that here. So we have, I'll put that a different color. So we have x plus 1, and then we can multiply this by x plus 2 times x minus 2. Okay, so now let's see what we started off with, right? So again, we started off with this function f of x equals x cubed plus x squared minus 4x minus 4. Now if we found we could say that we can break it up into factors, right? So we have x plus 1 times x plus 2 times x minus 2. Recall that our output here, f of x, is the same thing as y, right? So now you might think, how can we find the zeros of this function? So the way that we can find the zeros of this function, so recall, so we can set y equal to 0, okay? And that's how we can find the x-intercepts. So what we have is we have 0 equals x plus 1 times x plus 2 times x minus 2, which implies that if we go ahead and try to solve for x, we have x plus 1 equals 0, we have x plus 2 equals 0, and we have x minus 2 equals 0. Subtract 1 on both sides, we get x is negative 1. Subtract negative 2 on both sides, we get x is negative 2. Add 2 to both sides here, we get x is 2. So these values, these three values you see right here, would represent our x-intercepts. And of course, what we could do is we could go beyond this. So if we start off with this example here and we factor it, we could actually graph it if we wanted to. So I showed that right here. So this is the function. So we have this is the same as this. So we have x plus 1 times x plus 2 times x minus 2. Okay, so as you can see here is we can graph it, and it is an odd function and it has opposite end behavior for the y's. And of course, like I told you in the previous assignment, you could graph it if you wish. Okay, now what I'm going to do is I'm going to show you another example. Okay, now see you later. Goodbye. Hello. All right, so let's say I give you this example now. So let's say we're trying to find the zeros of this particular function. So kind of what I showed you earlier, right? So let's just consider the constant term and consider all the possible factors of 9. So let's see, 1 goes into 9 nicely, so we have plus or minus 1. 3 goes into 9 nicely, plus or minus 3. And then 9 goes into 9 nicely, so plus 9 is minus 9. So any of these values here, if we use syntactic division, if we get a remainder of 0, then that means that we can change that 0 to be a possible factor. Okay, so let's try it. So let's try 1. Let's try 1. Okay, and then let's go ahead and try this here. So 1, negative 3, 11, negative 9. Okay, so let's use syntactic division on this. Drop down to 1. 1 times 1 is 1. Then we have a negative 2. Then we have a 9. Oh my gosh. Wow. Look at that. So we got super lucky there. So since we got super lucky here, this expression here is going to be the same thing as x minus 1 because a is 1, right? A is 1, so we have x minus 1. And then we're going to multiply it by x squared minus 2x plus 9. Okay, so as we go through this, let's try to see if we can, if we want to find the zeros, as you can see here. Let's see if we can do that. So recall that if we want to find zeros, what we're doing is f of x is the same thing as y. So basically we're dealing with y equals times x minus 1 times x squared minus 2x plus 9. So in order to find our zeros or x-intercepts, basically we need to set y equal to 0. So when we set y equal to 0, what we have here is we have 0 equals x minus 1 times x squared minus 2x plus 9. Okay, so what we have is if we set this factor, so x minus 1 equals 0, if we add 1 to both sides, we get x equals 1. Okay, now what we have here is if we try, we're going to run into issues if we try this here. X squared minus 2x plus 9 equals 0. Okay, and you might be thinking, well, how would we go ahead and try to solve for x in this way in order to find our zeros? So what we can do is, well, we can try to use quadratic formula, or maybe even completing the square. Any of those would possibly work. I have a feeling probably 70% of you, maybe 80% of you, will probably end up doing the quadratic formula. Okay, so let's go ahead and use the quadratic formula on this guy. So if we use quadratic formula, this means a is 1, b is negative 2, and then c is 9, right? Okay, so I'm thinking I might run out of room here. I'm just going to put this on the side. Okay, so let's go ahead and do that. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's simplify this. So this is a positive 2 plus or minus square root of, and then we have 4 minus 36. We're dividing this by 2. Okay, so we have x equals, so 2 plus or minus square root of negative 32, and we divide this by 2. Negative implies that, as you can see here, we're going to get two imaginary solutions. So what that means is that the zeros are going to be imaginary. So basically, you cannot see the x-intercepts if you were to graph them in this case. So where x's are going to be imaginary. But we can still solve for x, right? So this is the same thing as 2 plus or minus I times the square root of 32 divided by 2. Recall that I equals the square root of negative 1. Okay, so as we go ahead and do this, we need to break up 32. 32 breaks up into 16 and 2. 16 breaks up into 4 and 4. We could actually stop here because, as you can see here, well, square root of 32 is the same thing as the square root of 4 times 4 times 2. We have our pairs here, so we need to find partners in crime. One gets shot, one comes out. So this is 4 times the square root of 2. Okay, so let's go ahead and replace that there. So I'm just going to go ahead and erase this here. So it was 4 times the square root of 2. So this expression, so we have x equals 2 plus or minus I times 4 times the square root of 2. Divide that by 2. If you guys need to see that again, just rewind the video really fast and you'll see that that's the same as that. Okay, so we get x equals 2 plus or minus 4I times the square root of 2 divided by 2. This, if we divide the 2 into each term, so 2 divided by 2 plus or minus 4I times the square root of 2 divided by 2. Then what I see here is we can reduce this. Well, 2 divided by 2 is 1, and then 4 divided by 2 is going to be 2. So this is 1 plus or minus 2I times the square root of 2. So what that means is if we wanted to find all the possible zeros of this particular function, that means we need to consider both the positive and negative here. So we have x equals 1 plus 2I times the square root of 2. And our other value is x equals 1 minus 2I times the square root of 2. So these three possible x values are our zeros of our function. And it just so happens these two on the bottom here are imaginary. Okay? Alright, so that concludes this problem. Please let me know if you have any questions. Okay, bye. Hello. Alright, so actually, before we move on, I just realized, well, what if some of you like completing the square? Alright, okay, so if you guys are completing the square, I'll show you how to do it that way too. So if you subtract 9 on both sides here, so this becomes x squared minus 2x equals negative 9. Then we need to add our blanks, right? We have blanks here, blanks here. Negative 2 divided by 2 is negative 1. Negative 1 squared is going to be positive 1. So 1 comes here. Then we need to factor this. So this is x minus 1 squared. And negative 9 plus 1 is negative 8. Okay. Take the square root of both sides here. So if you take the square root of both sides, so this cancels. And we get x minus 1 equals, the negative implies that I is going to come out. So we have I times the square root of 8. And then what we would need to do is we would need to go ahead and break out 8. So 8 breaks down into 4 and 2. 4 breaks down into 2 and 2. So this means square root of 8 is the same thing as square root of 2 times 2 times 2. Look for partners in crime. One gets shot, one comes out. So we have 2 times the square root of 2. So this is I times 2 times the square root of 2. Or in other words, if we flip around, what we have there is we have plus or minus 2I times the square root of 2. Okay, so if I were to write this here, so this expression here, up here, just so I can show you guys a little bit more work, right? So what we can do is we could add 1 to both sides here, and if we add 1, so this is 1 plus or minus 2I times the square root of 2. And as you can see, that's the exact same thing that we got earlier if we consider both the positive and negative values of this. Okay? All right, so now I'm going to go into the next example. I'll see you later. Okay, bye. All right, now let's jump into this example. Okay, so let's say we want to factor this particular expression. Okay, so let me just help you out with a little bit of reasoning. Okay, so if we want to factor this, let's say we were to set f of x equal to 0. Okay, if we set f of x equals 0, we get 0 equals x cubed minus 8. Okay, so in other words, if we flip around the equation, we have x cubed minus 8 equals 0. Okay, now if we were to add 8 to both sides here, then we get x cubed equals 8. Now recall, so now we have a cube here. So if we have a cube here, we can go about getting rid of that cube. Instead of taking a square root, like if it was x squared equals 8, we take square root. If we have a cube here, we need to take this thing called a cube root. Okay, so we take a cube root here, and this is going to cancel. And if you guys don't understand what a cube root does, basically if we have 8, well, we're figuring out, well, if we have here, so we have x times x times x is 8, right? We're figuring out, well, if you multiply 3 of the same number together, how would you get 8? So, well, let's try it. 2 times 2 times 2, right? So that's going to be 8. So that means a cube root of 8. So the cube root of 8 here is going to equal 2. Okay? This implies that let's try to use this value of x in order to try and factor this by using synthetic division. Okay, so let's use synthetic division, given that we found that one of the x-intercepts was 2. Okay, so what we could do is 2 could go in our corner when we use synthetic division, and then we go ahead and write, so we have x cubed, and then we'd have to write 0x squared plus 0x, and then we have a minus 8, right? So we have 1, 0, 0, and negative 8. And then what we can do is we can go ahead and do this. So 1 drops down, 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, 0 plus 4 is 4, 2 times 4 is 8, negative 8 plus 8 is going to be 0. So that means if we're to factor this expression, x cubed minus 8, so this means x cubed minus 8 is the same thing as, since this is a, this is x minus 2, right? And then what we have is we have this expression here, 1x squared plus 2x plus 4. So we have x squared plus 2x plus 4. Okay? And this would be how that factors. Okay? So next, I'm going to show you another type of example. Okay? So let's say for this next one, I ask you to factor something like x cubed plus 125. Okay, so same idea. What we're doing is we're going to set f of x equal to 0. So we set fx equal to 0. So we have 0 equals x cubed plus 125. Flip this order around, just make it a little bit nicer. So x cubed plus 125 equals 0. Okay, so what we're going to do is, let's say we subtract 125. So if we subtract 125, we get x cubed equals negative 125. Okay, now this is where it gets a little bit interesting. So cube roots actually can be negative. Okay, so what we have is we can do the same thing. We can take the cube root of both sides here. So the cube root of both sides here will basically imply, well, what numbers, if you multiply 3 of the same number, will you get negative 125? So if you do a little bit of reasoning, well, 5 times 5 times 5 is going to be 125, right? But if I tag a negative in front of all of these here, what's going to happen is 2 negatives become positive and we're left with negative. And that's how we get negative 125. So what this means is, basically, if we take the cube root of this means that x is going to equal negative 5. Okay, so as we use the synthetic division for this, now we can use this value and put it in the corner. Okay, so now we're going to use this value, put in the corner, so we have negative 5, right? And then we're going to take this. So we have x cubed, so x cubed, and then we have a plus 0x squared plus 0x, and then we're going to add 125. So we have a 1 followed by a 0, and then a 125. Okay, so now let's try to use the synthetic division on what we have here. So first, this number drops down. Negative 5 times 1 is negative 5, so negative 5, multiply 25, 25. Negative 5 times 25 is going to be negative 125, which is going to be 0. Okay, so if we were to factor this, so this means x cubed plus 125 is going to be the same thing as x plus 5. And the reason how I got x plus 5 is basically this is x minus a. So x minus a negative 5 turns this positive, and that's how we get x plus 5. Okay, and then we're going to write out our other expression, which is 1x squared minus 5x plus 25. So as you can see here, this is x squared minus 5x plus 25. Okay, so this right here is our answer. This is how we would factor this completely. Okay, all right, and that's basically it. Okay, so please let me know if you have any questions on this. Okay, bye.